Today's notes are on 4.3. We're going to do 2 days on this. So the first day is just dividing polynomials by factoring. Tomorrow we'll do long division and synthetic division. So when we divide polynomials to find their quotients or factors, we are taking equations in standard form and we're converting it to intercept, but this chapter we're going to call it factored form. So we're going to review a few methods, but we're also going to learn a few methods. So our first review method is the GCF, greatest common factor. What can you divide all terms by? Okay. And so in this one, we can divide everything by x and x, which means we have a final answer of x parentheses x plus 5. When you write factored form, it's really important to not lose your GCF. Okay. This one we can divide by 2 and x. Okay. And I know this because 16 can also be divided by 2. If you check your purple factors page, you can also look for like 2 and 16, and you look for the biggest number they have in common on your factors list. This last one should always cancel out. Okay. And so when you write your final answer, 2x parentheses x minus 8. I can also check to make sure I'm correct. 2x times x is 2x squared. 2 times negative 8, 2x times negative 8 is negative 16x. Now, 10 and 5 can both be divided by 5. And here's where we have to be really careful. If there's a negative in front, then we need to divide by a negative because our goal is to end up with a positive x inside the parentheses. Okay, so this has to match. And then right here, remember that we always want no x's at the end. So we also want to make this one match. Okay. So now our final answer is negative 5x squared. Negative 10 divided by positive 10, we want a positive number. You guys see how it's positive 2? X cubed, there's 3 x's, cross out 2 of them, or take out 2 of them. I have 1 left. 5 divided by 5 is 1. Please don't cancel it all out and make it disappear. Okay, the 1 is important. So if you have a binomial in your answer, inside the parentheses, there will still be a binomial left over. Try these 3 yourself. And then you can always check on, actually Google will possibly factor these for you if you type it into Google and say factor. Okay, don't cheat and do it, but like try it yourself and then check your answers. Okay? X method. For our X method, we want to find 2 numbers that multiply to C, A, B, C, and 2 numbers that add or subtract to B. How do we know if it's adding or subtracting? Well, if C is positive, then we're adding to B. If C is negative, then we are subtracting to B. Okay? So I'll set up my diamond, or X. We're going to go positive 24, so I'm going to add to 11, which will be 8 and 3. Now this is where you have to find the numbers yourself. Once I tell you the numbers, it's really easy to be like, oh yeah, of course. But if you can't find the numbers yourself, then it's going to be a little difficult. Okay, we need to add to 18, but we're adding to, multiply to positive 18, but add to a negative 9. So we know that 6 and 3, if you guys look at your factors list, 6 plus 3 is positive 9, but I don't want positive 9. So what do? I just go in and I switch both signs because my goal is the opposite number. So if you can switch both signs, then you'll be fine. Okay. So this will be x minus 6, x minus 3. When we are writing things in factored form, we are not switching any signs. You keep what numbers you find from the x. This last one, we're multiplying to negative 24, so I want to subtract to get to negative 2. And so I think 6 and 4 will work, but 6 minus 4 is positive 2. But since I want negative 2, all I have to do is switch both signs. And so my final answer is x minus 6, x plus 4. Try these 3 on your own. Difference of squares only works if you have like a perfect square, an a squared minus a b squared. Okay? And this is because we need two numbers that multiply to negative 36 and add to 0, and the only numbers that add to 0 are like positive 6 and negative 6, positive 5, negative 5, positive 2, negative 2. But do you see it has to be like 2 times 2, 5 times 5, 6 times 6. So when I see perfect squares like this, for both of them, then I know it's x times x and 6 times 6. One of them is going to be a negative. Okay, and this only works when it's a negative. If this was a positive, you would have to write not factorable. So here our answer will be x minus 6 and x plus 6. Let's do another one. Hopefully you see that this is x times x and negative 10 times 10. So x plus 10, x minus 10. It doesn't matter which one you write first. Okay. Example 3c looks a little different, but 9 is a perfect square. 3 times 3 is 9, and then x times x is x squared. And then this one will be negative 7 times 7. And so now I have 3x minus 7 and 3x plus 7. If you multiplied this out using a box method or distributing or FOIL, you would see that the middle two terms would cancel out because there'd be one positive 21x and one negative 21x, and that gives us our final answer. Let's keep going. You try these 3. Okay. Sometimes we remember, hopefully, that if there's a number in front, you cannot use the x method. So we have to try the GCF first. So in this case, if you can, always check for a GCF first. Okay. So I'm going to divide by 5, 5, and 5, and then I realize, hey, there's an x over here that I don't want, right, into, like, in my equation or expression. I don't want an x at the end. So I'm going to divide everything by x as well. That gives me 5x. Please make sure it stays. X squared minus 7x plus 10. Do a quick x method. 10 and negative 7. Since it's positive, we're going to add to negative 7. Negative 5 and negative 2. So I have 5x, which follows all the way down. X minus 5, x minus 2. 2 for you to try as well. So the answer that you should get at the end is x 2x cubed. Let's see, and then we'll have x minus 3, I think, and x minus 5. I think I'm correct here. Check me if I'm wrong. Oh, I'm sorry I had them both divide by 2. Okay, so this one we had to divide by 3 x's because there's 3 at the end. This one is only 1x. Sorry about that. You know what? We're on brunch right now, so I'm going to try to finish this recording. So this last method actually continues for both of them. So the first step we do, at this point, notice that there's no GCF that we can take out. Right? So you can't divide and get rid of that number in front. It used to mean that we had to do the quadratic formula to solve for x, but in this case we don't actually want to solve. We just want to write it in factored form. And the quadratic formula doesn't help us write equations in factored form. So we're still going to start with an x method. So I'll do that over here. The only difference now is instead of just c, the last number, we have another number we need to worry about. So it's going to be a times c on top. 5 times 2 is positive 10. Since it's a positive number, we are going to try to add to 11. Hopefully you see that is 10 times 1. And so what we're going to do with this 10 and 1 is we're going to split 11x into 10x and 1x. And then I'm going to bring down your 5x squared plus 10x plus 1x plus 2. Okay? So I'll draw some arrows so you see where those are coming from. Now, what's the reason for this? Well, what people have found is that you can actually do something called factor by grouping when you have 4 terms, which is what we'll be doing down here. But what you can do is create 2 groups, this first 2 numbers and the next 2 numbers. Okay? And so we're going to do something called taking the GCF of both, and I sometimes call this the double GCF method, where I'm going to figure out what happens to the first 2 terms. They can both be divided by 5 and 5. And they both have an x and an x. This one tricks students. 1x plus 2, you can't divide by anything. It just means it's 1. And since it's positive to begin, we're going to use the positive. Okay, remember this one always matches. Sorry, that 1 disappeared. Okay, now this is where it starts to get a little weird. You're just going to write each problem as if it were separate. So like I'm going to cover this up. And my answer would be 5x parentheses. And what's left? Well, 5 divided by 5 is 1. Take out one of the x's from x squared, and I have x. 10x divided by 5 is 2. And then I'm going to do the same thing over here as if we didn't have this part, right? So the 1 is your GCF, and then we have 1x plus 2. This is really important to notice that you have to have the same factors inside the parentheses. If you don't, this method doesn't work. And so the last thing to do is write your final answer. The 2 GCFs go together. So take a look. GCF and GCF go together. 5x plus 1. That's one of your factors. And then the other one, don't write it as squared. Please write it as 1x plus 2. Now, why is it not squared? Because when I distribute 5x times this and 1 times this, do you see how it goes backwards? Right? So we don't need a squared. This is our final answer. Okay. Let's do another one just to get comfortable. A times c. 4 times negative 3 is negative 12. So I'm subtracting to negative 4. And those two numbers are negative 6 and positive 2. And this is multiplying to 12. So we're going to split negative 4x using those 2 terms that I found. 4x squared minus 6x minus, plus 2 x minus 3. Make sure that you add x's in. Okay, so that's a common mistake. So make sure 4x is the same as negative 6x plus 2x. Double GCF. Okay. This first one can be divided by 2 and x, 2 and x. This one is 1 and 1 again. If you wanted to, you could have switched the 6 and 2 as well. Okay, so maybe I'll actually do that to show you guys something different. Let me write that in, because this might happen sometimes where you do something a little different. Okay, so this is still 2x and 2x. And then this one, though, can be both be divided by 3 and 3. Since there's a negative, please make sure you're dividing by negative 3. That's what I wanted to show you guys right now. So the GCF here goes 2x, parentheses something, and negative 3, parentheses something. And the parentheses need to be exactly the same. 4x divided by 4x squared divided by 2x is 2x. And 2x divided by 2x is 1. Negative 6 divided by negative 3. Notice we wanted a positive number here. Negative 3 divided by negative 3, positive 1. We're basically there. Please don't forget to write your final answer. This happens a lot where students stop too soon. GCF, GCF go together. And whatever's left should be the same, so we only write it once. So please do try, sorry I moved that a little fast, please do try these 3 problems on your own. Okay? Method C of factoring helps us factor when we have cubic functions, okay? And this only works when we have 4 terms in the polynomial already, because what we're going to do is skip the a times c x method, and we're going to go straight to double GCF. And so we are going to divide this first one by 5x and 5x, and this next one will be divided by 3 and 3. Since the first term is positive, we're dividing by positive. So then we have 5x parentheses plus 3 parentheses, and we need to make sure that whatever's inside the parentheses is the same. This will be x minus 2 and x minus 2. If it's not the same, you would have to stop here and write not factorable. Okay, for today, our goal will have them all be the same. GCF and GCF go together, and then what's left is the same, so you write it one time, and that's our final answer. I'll do one more. GCF for both of these, and GCF for both of these. So I'll have x squared minus 1 is my other GCF. And this will be x plus 1 and x plus 1, because a negative divided by negative is a positive. So now I have x squared minus 1 as my GCFs, and then I have x plus 1. I'm going to pause here before I box this as a final answer, because you'll see that x squared and negative 1 are perfect squares. So you can keep going and write your final answer as x minus 1, x plus 1, and then bring down your last term as x plus 1. Well, since there's 2 x plus 1s, instead of writing it twice, I'm ultimately very lazy. I'm going to write x plus 1 squared. Okay. Try the last 3 problems on these notes and see if you can get them correct. Once again, these problems are definitely, you can use PhotoMath to check them, or even type it into Google and have them check it for you.